Patrick or Kenneth. You can unmute and ask if you want.
Yeah, we can give 1 more minute.
Jeroen has a question.
Yes, I do. So
Shoot.
what about, for example, a multifunctional that you have on a big office space going over the WAN and wants to scan to email? If you give an IP, if you do it on IP location, that's still the whole site that you're giving access.
Yeah, that's correct. Yeah, because you actually authorize the one IP address, and therefore the whole site still has access. But keep in mind that only allowing one IP address is better than allowing the whole world to use it.
So yeah, but is there a better solution than to do this with these perhaps slightly older MFPs, or are we meandering towards universal print and other solutions?
That's the way that we are going. We do see some solution where, for example, you use an internal SMTP server, and you actually make the connection towards your Exchange Online environment in a secure way. That's another way to do it. But we see a lot of these old school devices which actually poses with an issue which we need to solve. Yeah.
Thank you.
You will face issues. Be ready for that.
Yeah, that's the one that I see the most, I guess.
Yeah.
Yes, not the whole world is modern yet, so you have to deal with it.
That's what we're here for, eh? To convince the rest of the world to move over.
Yeah.
All right. Okay. Well, thanks again, guys. I think we are ready for our second topic for tonight. I think that Heini is in the room. So Heini, if you are ready, I'd like to welcome you to our MC2MC evening, and the stage is all yours. Please go ahead.
Thank you so much, and thank you for having me. It was kind of nice to catch up on the previous session as well and listen to what is going on. And now we're actually going to transition to a topic with data. So let me just get the screen sharing going and we can get on the way. All right. So big data is kind of one of those topics that seems to be a lot on people's lips, and it's something that is talked about a lot. But then there is kind of these scenarios that when you wonder, like, do I even have big data? And how do I determine when I should be using these big data architecture patterns that are available all over the place? But how do I know whether my data is big enough to be actually using these? So just to kick off this entire topic, we first have to start with understanding even what is meant with big data. And so when we talk about big data, there's often the 5 V's that are used to describe it, sometimes also 3, but actually it's really important to have all the 5 V's to really understand what is meant by this. And so the most obvious that comes into mind with big data is volume, because that is telling us about how much data do we have. Is it gigabytes? Is it terabytes? What is it? It's just big data includes that you need to have a lot of data. And the interesting thing is that there's no kind of specific amount that is agreed on what constitutes as big data, but it's more like you need to have terabytes or even petabytes of data. So it's not even gigabytes isn't yet kind of counted as big data. So to kind of say that you have big data, you need to have a lot of data to work with. The second aspect here is velocity, and that is referencing to how fast are we accumulating data? How fast is it coming in? Are we just getting data every day, or is it coming every second, and so forth? There are many aspects that then will kind of contribute to having a large velocity of data. The third important aspect is variety, and this is talking about kind of having different kinds of data. So not just having typical relational databases and things like that, but having kind of a whole scope of data from relational to even photos and things like that. Next, we kind of get to the 2 ones that are sometimes left out, but they're really crucial when we talk about data. And the next one is veracity. And this is talking about how trustworthy is your data. If you're going to do something with your data, you need to be able to trust the results you get out of it. If you can't rely on the results, then it's kind of a waste of time to be doing anything about it. So this is actually really, really important to get right. And if your data doesn't have the trustworthiness, then you need to do something to make it happen. And as the last point, we have value. And value is talking about, is this data valuable to your business? Does this data have some kind of value that it can give to you from where you can gain some kind of benefit? It doesn't matter whether it's financial, whether it's for the people's well-being, or whatever the benefit would be, but it needs to have some kind of value. Otherwise, again, we can kind of wonder, like, why are we even doing anything with data? But kind of the central idea with working with data, why we're even doing it, has to do with the fact that we want to gain some kind of insights. We want to either see our data, we want to draw new insights out of it, but probably no one is working with data just for fun. It's a lot of work. And so probably we're trying to get something out of it, something valuable, draw some kind of new insights. But if you're listening to these definitions, at least when I'm working with customers, there's a lot of situations where the data might not be quite so big. So for example, there's not quite the volume in that sense as it is described in big data. And then one might wonder more like, well, maybe it's something like medium data. Yeah, there's velocity and variety and veracity and value, but it's not quite that big. Or even maybe you have just small data. So in that case, what should we be doing with our data? Can we use the architecture patterns that are available in Azure, for example, or what can we do? So to answer that question, what we're going to be doing today is first we're going to walk through an Azure reference architecture for data platforms or data platform solutions. Then we're going to look at a scenario where you might not have all of these present. And then lastly, we're going to look at how you can make this reference architecture your own, because reference architectures are always just reference architectures, and most likely your scenario isn't going to fit exactly to that same template as is intended with the reference architecture. So I'm Heini Ilmarinen. I live in Finland. I work as a DevOps consultant for Polar Squad, which is a Finnish small consulting company that focuses solely on DevOps. I work both on the infrastructure and data side of things, so that's kind of where my data passions come out from. I'm also a Microsoft certified trainer, so I run some Azure trainings occasionally. And you might kind of see, I tend to put an architecture twist to anything I talk about, because I think it's so crucial to know how all the bits and pieces fit together. And I actually happen to be a mathematician by education, but then moved into IT. And yeah, if anyone wants to talk about math, I'm up for that as well. And as you might notice, there will be some doodles around in this presentation. So let's get to the first part of the session, which is the Azure reference architecture. And so what I'm going to base this session on is this data platform end-to-end reference architecture that can be found in the Microsoft documentation. I can toss that link into that chat once we're done, and then we can kind of move from there. And so what we can find in this picture is many, many things. And to make any sense out of what is each piece for, we kind of have to walk through it piece by piece and understand what each of these components are doing in this scenario. Otherwise, we'll have no tools to determine which pieces we might need in our scenario if we don't understand the purpose of each of these components. So if we start from the very beginning, we're going to start with some kind of data sources if we're gonna try to make a big data solution. And for example, we might have some kind of more traditional relational databases, because a lot of our systems might be actually using relational databases behind the scenes, and we might want to be using some of that data. But in addition to that, we're probably going to start to have some semi-structured data. So things like XML, JSON, even CSV files and so forth. So files that have structure but are not a relational database. In addition to that, we are starting to have more and more unstructured data. So things like photographs and video and kind of free-form written text even, and all kinds of things are coming out into things we might want to pull onto our data platform solutions. And lastly, of course, we can also have streaming data, which kind of brings a whole new dimension to this data platform thing. And kind of based on what kind of data sources we have, then we'll be able to kind of assess what kind of volume do we have? Do we have a lot of data? We will be able to look at what kind of velocity there is. We're going to be able to see, is there a lot of variety? But with the last two, determining whether there is veracity, we will probably need to do some data cleaning even to ensure that there is actually trustworthiness for our data. And then lastly, we should kind of always be keeping in mind that our data needs to have some kind of value for us. And so as we move forward, also keep in mind that this reference architecture is built based on the assumption that you have all these five. You have a lot of data, it's coming at a high speed, and there's many, many types, different types from the relational to the completely non-structured type. And also it is assuming that there is some veracity, so you can trust it, and also that there is some value in this data for you as well. So all of the pieces that are then chosen for this architecture are based on this assumption that these five things are true. So if we start walking through, as the first phase, of course, we have to find some kind of method to load and ingest the data. If we want to start working on a data platform solution, we first need to gather all the different data sources into one place. And now it means that, now I just lost a word. I'm just getting it in Finnish in my head. But dependent on which kind of loading you need to do, you might need to use different solutions. So for example, for the relational, semi-structured, and non-structured data, you want to use Data Factory. So this is used whenever you need to do kind of batch processing for your data. So you're moving a bit of like larger sets of data at one time. And Data Factory will allow you to build pipelines that will give kind of definitions how you want to move that data. Do you want to move it as it is, or do you want to do some cleaning on the way, or do you already need to do some transformations? Then we have the streaming side, and that is kind of a whole different ballgame. And for that, Data Factory isn't optimal. You can get away with some things on Data Factory, but not everything. And in most cases, you would set up for streaming data something like event hubs. And so we're kind of bringing in the streaming data then in a different way. And if you have looked into the architecture patterns, you might notice that this is actually kind of mapping out this Lambda architecture that is often used for kind of having this hot path, which is the streaming data coming in all the time, and then having the cold path, which is this batch processing path for your data as well. So you might be using both of those. Then as we're ingesting the data, we of course want to store that data somewhere. We need to have some kind of place where we put it. And so as the central component here, what is taken is Azure Data Lake Storage. And into the Azure Data Lake Storage, we want to take both of these paths. We want to take both the batch processing path, so Data Factory, but we also want to bring in that streaming data because we might want to aggregate all that data as we're moving towards the future, and we want to kind of combine our data in different ways. Then if you start to have more kind of demanding needs for the data structures, because in a data lake, your data is stored in flat formats. So you're going to have like CSV files and Parquet and things like that. But if you need to have some more structure to your data, you might need a relational database. And what is used in this reference architecture is Azure Synapse Analytics. And what this is referencing now to is not the full suite of Synapse Analytics. We'll get to that in a bit. But this is referencing the old data warehouse portion, or the part that is called dedicated pools currently in Azure Synapse Analytics. So if we need that structure, we want to do more like traditional data warehousing type of things and create a star schema and do that kind of very kind of heavy reporting on our data, then we will need to move it somewhere that supports that. And that something would be Azure Synapse Analytics, the dedicated SQL pools. Then, as we've been able to store our data somewhere, then we want to do some processing on it. So this means when we're processing data, this can mean, for example, doing transformations on the data, so combining different data sources in a new way. It can even mean preparing your data for machine learning purposes or preparing it for a particular application. It depends, like, what are you going to use the data for? And so in the preparation phase, in the processing phase here in the reference architecture, what is used is Azure Databricks. And so Databricks is kind of a very commonly used tool in data analytics and processing and even machine learning, even not kind of outside the scope of Azure as well, that where you can use notebooks and Python and so forth to do all kinds of processing on your data. And the neat thing here is that you can, with Databricks, you can work with data in your data lake, but also with the data in the Synapse Analytics as well. And then when you've kind of done the preparation in Databricks, you're also able to combine this with services like cognitive services or even Azure Machine Learning as well. So it gives you a lot of flexibility and you can integrate with other services as well. And now we've kind of lost our streaming path. So there can be also the chance that when you're bringing in your streaming data, you want to do some kind of processing on the data on the fly. So for example, do alerts on values that are not between some kind of limiting values, for example. So if you have a heat sensor and the heat rises above a certain temperature, then you could alert on that on the go. And you might have this kind of needs on the way. So to do those things, really putting the data into data lake is not going to be a functional way, but we need something that can do analytics on the stream. And for that, we can then use stream analytics in Azure. As the last phase, what we have here is the serving. So this is the layer where we bring the data to a format that then can be used by end users. So one very common way to work with or do the serving of data is to use Power BI when people, for example, have needs to visualize the data. And especially based on this kind of data warehousing type of data, we often need to have some kind of visualization layer to make any sense out of it. And the thing is, with Power BI, we can actually also create visualizations on the streaming data as well. So we can have dashboards that are completely working on the live data and updating as the data comes in. We can have these streaming data sets in Power BI. But also what is possible is that you can write this data that you're working with, for example, processing it with Databricks, you can then write it to any database service that you would like. But in this particular example, what is used is Cosmos DB. And then we need to have the consumers in there that are actually using this data. So it can be just individual users. It can be kind of reports in Power BI. It can be any kind of application as well. There are many, many options that you can work with when you are talking about the consumers. And so the consumers just can be anything that where you want to leverage this data from. So now we have kind of a general understanding of the phases that we go through when we're working on a data platform solution, especially when you're working with big data. And you need to kind of account to those 5 V's and ensure that the platform is able to handle all of those. So this is everything that you're going to need at that point. And so there has actually been some changes on the data platform services side in Azure lately. And having this Synapse Analytics here in the picture might be already kind of pointing to the direction I am referencing here. So we have gotten the kind of the full-fledged Azure Synapse Analytics solution, which is no longer just the old data warehouse service. There is many more capabilities to it. And so I just wanted to also kind of point where that would fit into this picture as well. And so if we kind of start to kind of look at this and see where that would fit in, we have, of course, the Azure Synapse Analytics at the bottom there as the relational database already in the picture. But there are many other capabilities in Azure Synapse Analytics as well. And it will actually encompass all these pieces, including Data Factory, including Data Lake, and including this data warehousing side, the relational database. But there is actually some additional pieces there as well, because within, well, let's just get the terminology straight first. So the Synapse Analytics, when we're talking about the entire suite of Azure Synapse Analytics, what we call it is dedicated SQL pools. But in addition, we also have the Data Factory type of capability in Synapse Analytics, which is actually called pipelines. Same thing, same code base, so you have all the same capabilities within Synapse Analytics too. Then we have the Data Lake side in Synapse, and that's kind of just standard Azure Data Lake that you integrate with your Synapse Analytics workspace. But then in addition, we have also two different kinds of analytic engines that we can use. We have serverless SQL pools, which allows us to run SQL-like queries directly on our data that is stored in Azure Data Lake. So this kind of is little taking out the barriers between just working with flat data and working with relational database data. And then within Synapse Analytics, we also have Apache Spark pools. So this is kind of quite similar to Databricks and allows you to do many of the same things, but there are also differences to it. And so you could either decide to replace Databricks with the Spark pools within Synapse Analytics, or you could use both of these or just keep using Databricks. So that's kind of why I left both in the picture, because you can kind of decide which tool fits your needs the best. All right. So we have a full picture of what is entailed to create a data platform solution, what services are needed, and what is the role of each. And we now also kind of get an understanding of how Azure Synapse Analytics also fits into the picture, because it can be a little bit confusing, because there's the old dedicated pools, which is the old data warehouse, and then there is the Synapse Analytics workspace, which has all these different capabilities that are like some of the other services that you can also have separately from Azure, like Azure Data Factory and the pipelines functionality in Synapse Analytics. But so, as I said in the beginning, when kind of this reference architecture was created, it was thought that people have big data. So what do we do with this solution if we don't have all the Vs? What if, for example, instead of having all of these 5 Vs, we instead have just variety, veracity, and value? What should we do with this reference architecture in that case? So if we kind of take, again, the full solution and start with it, and we kind of start poking at it and seeing what we might want to replace and what we might want to do differently if we don't have such a huge volume and we don't have such a huge velocity. So what often happens, at least at the customers where I've been working with, is that they might not have IoT data or any streaming data, or they might have streaming data, but it's in such closed up kind of isolated systems that there's no way to get the data out easily. So we decide to start first working without the streaming data, and then kind of we decide to add it later on. So this, for example, would contribute to not having such a high velocity of data coming in. So what would, of course, happen for this reference architecture is that we can just kind of start pulling up pieces. We don't have the streaming data anymore. We can take all those components that are related to working with this streaming data. We can just kind of pull them out of the picture. It means that we don't need the event hub. It means we don't need the stream analytics, and it kind of also, we don't also need one of these Power BI boxes here with the streaming datasets. So already our architecture has become quite a lot simpler, and this is kind of a standard scenario one might start working with. But there is also a little peculiarities here as well. You might, for example, notice that within this picture, we have Power BI Premium, and you can definitely get started with just regular Power BI with just some pro users and just creating your dashboards using that method. Now, of course, the situation is a little different because we have Premium per user. It's not kind of a monthly payment anymore, which it used to be. So that gives a little more flexibility to how we might want to do the Power BI side. Also, sorry, I forgot to say, you might want to replace the Synapse Analytics old data warehouse side with, for example, regular Azure SQL. If your kind of database needs don't require so much compute or so forth, you can kind of have a slightly lighter option there for the database. The Synapse Analytics dedicated pools is definitely kind of the most full-fledged service for data warehousing scenarios. But also, if you have a little more lightweight situation and you don't have so much data, you can get quite far with Azure SQL as well. It is just not optimized for that massively parallel processing the same way as the Synapse Analytics dedicated SQL pools is. So there's the difference. The whole engine of the SQL is slightly different, how it handles queries and so forth. As the last bit I would kind of put into focus here is the Cosmos DB side. So really Cosmos DB is really optimized for the scenarios where you want to do global data distributions and so forth. So if you don't have that kinds of needs, you can change it to Azure SQL. And of course, this entire branch with the Azure SQL and the application, you could replace that and take it out if you are only doing visualization on your data as well. And so really what we can do with this reference architecture is take it as it is, look at the different kind of parts that are in there and kind of go around the different components and see how we can, which parts we are actually going to use. But this is kind of one of the most common setups that there might be. All right, so as the last portion of this session, we're going to look at how we can then make it your own. Because like I gave you now one example of what if you don't have all of these, but what if your needs are slightly different? You're not doing an application, you're doing visualization and so forth. How are you going to go like systematically through this reference architecture and be able to translate it to your particular needs with working with data? Whether you're just creating a data platform to do visualization or whether you're doing a data platform to do API management and create a full API platform where people can then even publish those kind of publicly as well. So there's like many options why you might be doing a data platform solution. It's not just one use case that might be your kind of inspiration to start even thinking about data platform solutions. So you need to be kind of strategic and check what might be the needs for your specific scenario. So to begin with, what you want to do is first start to look at the functionalities of the data platform and think which ones of these functionalities are the kind that you are going to need. And so what that means is that you have the full reference architecture. I would actually do this, like have the full reference architecture in front of you, even print it out on paper if you like, and kind of start first thinking like, which of these components do I need? So very often is the case that, well, we're not quite ready to start to do machine learning yet because we don't even know whether our data is valid. We don't know whether we need to do something just to make the data clean and make it trustworthy. And that is kind of the one part here where you might want to start off. And you might not have this need to create an application and create the data from this data platform for this particular application. So you can kind of look at the entire picture, go around and circle the points that you need, or kind of cross out the ones that you don't, and choose the particular services that you want for your solution. As the second point, what you want to do is to then scale or replace the services that you want to use. So kind of what we did in the previous example, you can, again, look at the solution, figure out what are the components that you're going to need, and whether you want to, in what scale do you want to use them. So as we're working in the cloud, the nice thing is you pay for what you use in most scenarios. When, for example, for Azure Data Factory, you're paying for whatever data processing you're doing. So it doesn't really matter whether you have just one pipeline in Azure Data Factory or if you have 100. The capacity will scale, the pricing will scale, and so forth. Everything will just scale accordingly. But with certain particular services, you need to actually scale the service. So for example, the Synapse Analytics dedicated SQL pools that is here as a relational database, you actually specify a certain amount of capacity for it. And this particular service is one of those that, at least when I talk to my customers, most people are kind of like, this is going to be expensive. And it kind of is. Like the smallest size is already a few €100 a month, so I think 600. But with the dedicated SQL pools, you can stop it, you can pause it, you can scale it when you need the large amount of compute for the parallel processing, and then you can scale it down when you don't need it. But this is probably one of the services that if you don't have a lot of data and you're just starting out with a small data set, it can feel a little overkill. And as I was describing before, you can of course replace that with Azure SQL, for example. And so you can kind of play around and see what would be the right place to start. And I would say with the dedicated SQL pools, yeah, you should have maybe a little more data to work with before you start using that in your data platform solution. But the nice thing about this reference architecture is also that you can also add services in here. So I mentioned that one of the reasons that someone might want to start working on a data platform solution might be that they have a full API strategy. They want to start being able to have their data managed so that both internal developers, for example, can get to that data when they need, and also even external developers could access certain APIs and use those for any of their projects that you would want to. And of course, if you're going to do that, you need a way to control those APIs. So you could then also add API management into the mix as well, and have that as kind of an additional feature that you are going to need in your solution. To be more exact, you're going to need something a little bit between your data lake and API management that will decide kind of what data it fetches, but just for the simplicity, I just added it only there. But you're going to need some kind of service that is going to do the processing, whether it's an Azure function or logic apps or whatever your favorite service might be. All right, as the last bit here, what we need to do is that you really need to implement like you do have big data. And what I mean by that is that you have your kind of final solution. One part of it, of course, is what services you're going to be using from Azure. But the other part is what are you going to do within each of these services? And where I see people going wrong the most is that they think that, well, I don't have big data, so I can just kind of, for example, toss all my data into the data lake and it'll be fine. I don't have to think about structures. I don't have to think about how I do my relational data modeling, for example. I can just kind of wing it since I have so little data, and these services are really optimized for big data scenarios. But that isn't true. Even if you have little data, the thing is that, of course, the amount of data that you have kind of grow. And then if you have kind of just started haphazardly, it is really difficult to expand. But also, if you are also doing everything haphazardly, what happens is that you don't get the best performance for your scenario. Even if it's small data, you want to keep your solution as performant as possible. And the thing is that for each of these services that are in the picture, you need to do quite a bit of planning. For Azure Data Factory, you need to plan out all your pipelines. How is the data going to be moved? Are you going to do some kind of transformations right away? Or are you going to move it first into the data lake and then do transformations? And you need to plan out all these things. And as mentioned, one of the really important aspects is also to plan out the data lake structure, because the data lake is possibly one of the services which is easy to kind of get wrong, just thinking that we can put data in however we want. But if we do that, it will get kind of messy quite soon. So really, we want to pay attention that with data lake, we have our kind of zones in there. We want to have the raw zone where we just bring in data as is. Then we probably want to have a curated area where that data has been cleaned. And then as the third aspect, we want to have the area where the data is ready to go and really kind of ready for those consumers and just for the next phases. So we really want to ensure that we're planning all of these areas of the data solution, really kind of taking our time to ensure that it will also scale in the future. Because that way we ensure that our solution will have really good performance. If we decide to scale it later, it will be easy. If we decide to add other services into the mix later, then we're able to add those as well. And so it's really kind of ready for whatever might come in the future for your solution. And it will then also give you more flexibility. So I'm gonna start wrapping up here to stay on time. So what we kind of went through here in this session was that we walked through the Azure reference architecture, and we went through all the different bits and pieces that make up that reference architecture, and what are both the phases, but also what is the role of each of those services that has been chosen for that reference architecture. We then walked through kind of I would say one of the most common scenarios I come across where you might not have so much volume and also not so much velocity because of maybe not having any streaming data. And then lastly, we looked at the process of what kind of steps do you want to go through to make it your own. So you want to first pick the functionalities you need. You then want to ensure that you have scaled the services to the capacities you're going to need, or replaced some that you might not need, and then also put in any services that you might need in addition. But also lastly, that you really want to kind of have the mindset of, I have big data already, even if you don't. Because the fact is that the people that really have big data, it's challenging to have massive amounts of data because you have to put a lot of effort to keep it on track, to really ensure that, you know, the relational database models that have been created are efficient and performant. It brings a lot of kind of challenges to the mix. And so you should really think that you actually have the right amount of data, because whether you have just a tiny bit of data or you have massive amounts, the core idea behind all of it is that you want to draw some kind of insights out of that data. And if you have a little bit of data, it's actually going to be a little easier to get those insights out and ensure that you have really, really good quality data, and ensure that your data is also trustworthy, because that is kind of a huge phase of just any data platform project, to ensure that that data is valid and it's good and you're able to work with it and get also trustworthy results as well. So even if you have little data, think that you have the right amount of data. If you have big amounts, don't get kind of overwhelmed. Just kind of start piece by piece and pick a smaller, maybe like a data set first, and start working with that and start working with the goals that you have in mind. So I really hope you have gotten kind of a general understanding of what are the different Azure components and services that you need to create an Azure data platform. You have maybe gotten inspired to get started and just figure out which components you use. And hopefully you've gotten also the tools to really kind of know how you can make that reference architecture your own. And most importantly, to know that even if you don't have big data, you can still use all the big data architecture patterns. Maybe not the massive services, but you can use the architectural patterns in any size of data scenario that you might have. So I hope you enjoyed the session. Thank you so much for joining. And I just tried to reserve a little bit of time that we can cover any questions that you might have, because often those are really fun and kind of make the thing concrete. And also, if you don't come up with question now, you can also kind of find me on Twitter and send me some messages or questions that you might have later on. Thank you.
Thank you, Heini, for the great session.
Thank you.
And really great graphics, to be honest. Really cool.
Awesome.
Does anybody have a question for Heini? Just unmute and ask it, I would say. I didn't see any questions in the chat, so yeah. So unmute and ask all the questions you want, I think.
Perfect. Yeah. Just to point out, there's a question about the doodling. I get this every time. But I draw them by hand on, I have a drawing tablet, like a Wacom board. You can also do it directly on a screen that you can draw on. Like I have a Surface, so I could draw it directly there, but it's a little challenging. So I just draw it by hand, and then PowerPoint does the animation, by the way. So there's a animation for any drawn objects. Question. Data Factory being phased out and replaced by Synapse? That is a really good question. I don't think I have the official answer. It doesn't seem like it's going to be phased out, at least at this point. Microsoft is, of course, pushing out Synapse Analytics, like the whole suite of things a lot, and kind of saying, this is the way to go, whatever data platform problem you might have, and always use this. But Data Factory is still going to be there. As I think I mentioned, is that Data Factory and Synapse Analytics pipeline section, they're based on the same code base. So they are still evolving side by side, and both are getting any new features that are coming out. They're coming to, well, 90% of the time they're coming to both of these. There's some kind of networking settings and things like that that are slightly different, I think, due to everything else that is included in Synapse Analytics. So, and I wouldn't be too worried about it if you're using Azure Data Factory, since you're kind of able to integrate that with Git, so you can get all your pipeline definitions out at whatever point you might need, and then import them into your Azure Synapse Analytics. It's so hard to say that over and over again. Yeah. So just keep using Azure Data Factory if you have it, and you'll be able to migrate to Synapse Analytics if it comes to that.
Anyone else a question for Heini? We're all quiet, so I think it was a great explanation. So
perfect. Yeah. Great. Thank you so much for having me. It was really fun.
Thank you for bringing this nice session. It was something we normally don't bring, but really interesting, and another point of view to look at in Azure. And I think, yeah, almost everyone can start working with data. So
yeah,
on top, great session.
exactly. Thanks.